Hello, programming languages students. Welcome to the first introductory video on grammars. Um, Grammars are actually practically used. There's some problems that you can solve with automata, and they can be helpful for theory, and even just as a state machine, sometimes they can be helpful for representations. Regular expressions are definitely used practically, but they're really more used for um, file searching and other purposes more than language definitions. Grammars are truly used for language definitions. So we're talking about programming languages. That's what the course is. And so grammars are actually produced. When you create a programming language, you must define a grammar for your language. How can you put things together? So for example, in IDEs, um, when you are working with a language, um, you're trying to build this environment for people to be able to write a language. You need to have clear feedback about whether the line of code they wrote is a valid line of code or not. And the thing that determines that is the grammar. So a grammar is basically a set of rules. And as we go through this video series, I'm going to make some quick videos going through the slides that are posted. Um, but basically, a grammar is a set of rules which govern how you can structure things in a language. So what is a valid line of Java code? Um, and so as you write these things, as you write these grammars, you have to think about all the potential things that could happen or problems that could happen with in your language, all the potential scenarios that could show up. And so grammars can get very, very complicated when you write them. And we're not going to get super complicated with grammars. We're going to do kind of a light introduction, and I think you'll be able to see how the rules work and how you can put things together. So in this example here, I have a very limited language for which I'm writing the grammar. The grammar starts with a sentence, so we want a sentence in our language. Well, the sentence must contain a noun phrase and then a predicate, where the noun phrase can be Brock, the name of my dog, or it could be the dog. And then the predicate, the thing that follows, could be ate or drank. So in other words, to make this happen, we would have a sentence, which we would then replace with a noun phrase and a predicate, and then you can think of this as another replacement. We want to replace the noun phrase with either Brock or the dog, and we want to replace the predicate with either ate or drank. So our whole language consists of four total possible sentences. Brock ate, Brock drank, the dog ate, the dog drank. So obviously this is a very simple language, and the rules can get a little bit trickier and a little bit more complex. And kind of to show you that, I'm going to open Java's grammar for a second, and let me flip my screen over. Let's flip over to, yes, to the screen. So this is, and let me zoom in because I know the video quality sometimes isn't great. So this is the actual grammar for the Java programming language. This is key information for anyone creating an IDE or trying to read or define or parse Java code. So you'll notice really quickly, I'm not going to spend long on this, but really quickly, there's a few initial rules that they define. They have square brackets with a thing denotes 0 or 1 occurrences of x. What is this in regular expressions? Well, question mark, right? 0 or 1 of a thing. So all this ties together, all these symbols and rules end up meaning things. So in Java, 0 or 1 of a thing is important. 0 or more of a thing uses curly braces. For us, we've been using star, and that's what regular expressions use and is pretty common, but here they decide curly braces is going to denote 0 or more of a thing. And then, of course, they have the same or symbol that we see elsewhere. So they define a couple things. They define a couple of rules, identifier, qualified identifier list. A lot of this doesn't, this is all very high level because we're really high up in the rules, but you might be able to pick out a couple interesting things, like a class or interface declaration involves a modifier, public, private, static, right? Whatever one or, and actually this is in curly braces, so 0 or more modifiers, followed by either a class declaration or an interface declaration, which are defined a little bit later. A normal class, an enum, normal interface, annotation type. So all these things and pieces that you put together are fit under the rules, right? So modifiers include public, private, static, final, all and tons more. And so these are all defined in the grammar. And so these specific text patterns are all defined. And so this grammar defines the Java language. So let's flip back to the slides real quick. Um, If you're really interested, you can dive more into Java's grammar, but in particular, if you ever wanted to write a language or figure out how a language works, seeing and understanding grammars can be helpful. And so every programming language that you create must define a grammar for it to be accepted and usable in any way, shape, or form. So that a set of rules can be created for IDEs. And so, like, if you think about it, without a set of rules, what makes a legal line of Java for, how, if there's no rule for that, how can we tell if code is legal? How could we even create a compiler to parse the code and do what it's supposed to do? Well, you can't. And so grammars are important, and every language you ever create has to be defined with a grammar, which is why we've been doing all this theory and getting to this point, is because when we talk about programming languages, um, we'd like to be able to use them. We'd also like to be able to know how they are produced in case we ever want to produce one ourselves or are involved in a team that's producing one. And so that's what we're getting at here. So we'll jump into a few more videos and talk about how we can write grammars and read them and get a little experience there. See you next time.